Very strong poles look like. So we are looking for the spontaneous reaction. So for spontaneous reaction, what should be the delta Z value? Delta Z should be negative. So you can see the first reaction, the delta Z is given positive value. So is it spontaneous or non-spontaneous reaction? It is non-spontaneous, so this is not our answer. The second reaction, the delta Z value is given a negative value, so it is spontaneous reaction. This one is the spontaneous. For the next two reactions, the delta Z value is not given. But look at that, what is happening. This fructose 6-phosphate is the product. Now the fructose 6-phosphate is the reactant and glucose 6-phosphate is the product. So what the reaction was done? Is it a reverse reaction? So if it is a reverse reaction, what will be the delta Z value for this third reaction? Is it going to be negative 0.5 kilocalorie per mole? So if it is negative, now is it a spontaneous reaction? So that is going to be the spontaneous. So now we find that 2 and 3 are spontaneous. What about this one? This one is just the opposite of this second reaction. So that would be the positive. So it is going to be non-spontaneous. Yes?
But with the ATP on the right end of it, doesn't that mean it's releasing energy, which would be exergonic?
That's a very good question. I like it. We are going to learn that kind of reaction. We call it the couple reaction. Couple reaction, that the sum of the two reactions. Now when we sum up, we also sum up their free energy chains. So net energy for this reaction is the negative. That's why the reaction is happening. If the net result is the positive, the reaction would not happen. So we will see lots of couple reaction in our cell, inside our cell, and that's what we are going to learn. So the answer is going to be then 2 and 3. So that is the D is the correct answer. So since all the reactions are going to happen inside the cell, all the biochemical reaction that happens inside our cell, I'm not going to discuss a lot about the cell here because you learned that one in another course, especially in the biology, and already you know many of the things. So, but make sure you know different parts of the cell. Because we are going to of the cell is the mitochondria. This is the very important. Because we know that mitochondria is called the cell's power plants. That means we produce here the ATP. Synthesis of the ATP molecule takes place inside the mitochondria. And ATP molecule is the accessible molecule that from where we can take energy for performing other work in our body. So in other words, I call the ATP is the money for our body. Like, for example, whatever we do in our daily life, indirectly or directly, is at the end, we need the money. Because that is the accessible things for doing anything. Like, for example, you are studying, you can say, okay, we are studying here for gaining our knowledge. Yeah, it is true. You can study, you can think, but at the end, it's not the knowledge. We all know that at the end is going to be the money, because if we don't have the money, we cannot do anything else. That is the accessible thing for our economics, right? It's the accessible money for the body. So wherever, so if ATP is not there, our body cannot function. So it's the final goal is to find out ATP molecule. So ATP synthesis takes place inside the mitochondria. So we need to know that what is the structure of the mitochondria. So mitochondria, we have the outer membrane and the inner membrane. And that space between the outer membrane and inner membrane, that we call is the intermembrane space. We can see that intermembrane space will play important role during the ATP synthesis. And also, in the intermembrane, you can see a lot of folding is there. That fold, we call it this kind of fold is you can see the zoom here. We call it the cristae, that part. In the cristae, ATP synthase enzyme is actually embedded in that membrane. So that ATP synthesis enzyme will be responsible for the ATP synthesis. So we'll see that one. And inside that we call it the matrix. And inside the matrix, then another important reaction we are going to see is the citric acid cycle that will happen in the matrix. That we do in our body, that we can call them metabolism. So another word that we are using is the metabolism. So what is metabolism? Any reaction that we do inside our body, that is called the metabolism. So metabolism is another word, is the biochemical reaction. If we do it inside the cell, it is called the metabolism. So we'll use that word metabolism, but don't be confused, it's just the chemical reaction. Any kind of chemical change in our body, we call it the metabolism. And any product that is formed from the metabolism, we call the metabolite. So, many reactions that takes place, like for example, carbohydrate to the carbon dioxide. Although it looks like it's a one reaction, but in our body we do not do just a single reaction to extract energy. We do number of reactions to produce energy. So that is most metabolic process, they have a sequence of pathway, and that sequence we can divide into three types of sequence that we see in our body. One we call is the linear sequence. From the name you can see linear sequence will be like if we have the A, it will convert it to B, B will convert it to C, C will convert it to the product, final product. So is the linear sequence we call. Another sequence, cyclic sequence. What is the cyclic sequence? If the final product is reproducing the reactant again. So like for example, A is going to B, B is going to C, C is going to D, and D is again converting to the A. So that process we call is the cyclic sequence, and another one is the spiral sequence. In our metabolic process we see. What is the spiral sequence? For example, A to B, we need 4 enzymes, enzymes 1 to 4. Same enzymes is responsible for D to C. Same enzymes are responsible for C to D. So a set of enzymes are doing the multiple reactions. In that time we call it the spiral sequence. So these are the 3 important sequences we see in our metabolic process. Now metabolism there are 2 types of metabolism in our body we see. One we call is the catabolism, another one we call is the anabolism. What is catabolism? You can see from the figure, a larger molecule is becoming a smaller molecule. And anabolism is just the opposite. A smaller molecule, number of smaller molecule is going to combine to give us the larger molecule. So catabolism, normally we see that catabolism produce energy. So the catabolism is look like the exergonic process, and anabolism is the endergonic process because it needs energy. So now can you give an example of the catabolism? What would be the example of an catabolism? That we do in our body. Sorry, what? Here, chewing food is the mechanical thing. Give me an example of the chemical reaction. Yep. So that means that, like for example, digestion, what she was telling, digestion we take, like for example, we take starch. Starch we know is the polysaccharide, lots of carbohydrate. During the digestion, what we do, we clip them, we break the starch long chain carbohydrate and make them monosaccharide or disaccharide pieces, small pieces. So that is a big molecule starch is becoming now small monosaccharide and disaccharide. So that can be an example of catabolism. Anabolism, can you give me an example of anabolism? What we do? Is protein a small molecule? We have amino acid, right? Building block is the amino acid. Number of amino acid is combined to synthesize protein. That is an anabolism, DNA synthesis. Number of nucleotide is going to combine to give us the DNA. So that is an anabolism process. So there are lots of anabolism reactions that we do in our body. Now this map is very important for us. Throughout the chapter, we need to understand this map because many questions is related to this map. If you can understand that one, it will be very easy for you that what is going on. Here is the food. And last step you can see the ATP. So our target from the food to producing the ATP molecule. As I mentioned that is our ultimate goal because the ATP is the money for the body. No money, no work for the body, no function. So we need at the end, we can tell there are lots of things that we need for coming from food to ATP, like we produce energy, that energy is for maintaining, we produce heat, that heat is to maintaining our body temperature, everything is there, but at the end, if we don't have ATP, body cannot function. It's the same thing. We study and everything at the end, we need to get money. If we don't have the money, we cannot survive. So now that food to ATP, we can divide into 4 stages. One stage 1, we call it the digestion. She was giving an example of the digestion. So now what is the digestion? What part is the digestion that we consider? We take food, and what type of food we take? Food can be divided into these 3 categories, either lipid, carbohydrate, or protein. These are the 3 types of food that we take. Now look at that, what is happening. The lipid, in the digestion, lipid will be converted to the fatty acid and glycerol. Lipid, what is the lipid? Lipid is the oil and fat, mostly. Oil and fat is the triacylglycerol. That's what we learned. Triacylglycerol. So in the digestion, what happened? We take food, we start to grind them with our teeth. We have saliva. We use a lot of saliva to grind our food. Saliva contains a lot of enzymes. So we start biochemical reaction just in our mouth. So saliva is a lot of hydrolase enzyme in the saliva. So they can hydrolyze some of the molecule, like big molecule, maybe like if it is a carbohydrate, a long chain polysaccharide can be disaccharide, or maybe a long chain can be just a 2 fraction or 3 fraction depending on. So it starts in our mouth, and then what happened? We swallow it, it goes to our stomach. In the stomach, there are a lot more enzymes, digestive enzymes, like the trypsin, chymotrypsin, that type of enzyme. So they start to hydrolyze the molecule to monosaccharide, and especially to the monosaccharide. So disaccharide will be monosaccharide, and the lipid is going to be fatty acid and the glycerol, because that's what we are going to get, the fatty acid and the glycerol. What will be the protein? Protein will be the amino acid fragment. So all the protein will be broken down to amino acid. So up to this process, we call it the digestion. So digestion is the mouth to our, and up to the small intestine. That one we can call is the digestion. So where the molecule is going to be, the larger molecule is going to be the small molecule, like the fatty acid is the lipid is going to be fatty acid and glycerol. Carbohydrate is going to be glucose and the other sugars, and protein is going to be the amino acids. So that is our stage 1. Stage 2 we call is the acetyl-CoA production. That is our stage 2. So the next step, we produce acetyl coenzyme A. This is CoA means the coenzyme A, acetyl coenzyme A, and we are going to see that what is the structure of that acetyl coenzyme A. So look at that. This is the common part for any type of food. The lipid is number of steps. There will be number of steps, number of reactions. Follow that one, then we will meet to the acetyl coenzyme A. Carbohydrate also, that is through the number of steps that we are going to meet at the acetyl coenzyme A, and the protein also, after number of steps, we are going to meet at the acetyl coenzyme A. So acetyl coenzyme A is production is the that is our stage 2. Once the acetyl coenzyme A is there, this is the fuel for the citric acid cycle. That is our stage 3 of food metabolism, is the citric acid cycle. So that there the acetyl coenzyme A is the fuel. That acetyl group, I don't know if you remember the acetyl group, this is this one, coming from the acetic acid. That is the acetyl group. These 2 carbons are coming from our food. So that is the carbon source is the important thing here. So these 2 carbons are coming from the carbohydrate or from the lipid or from the amino acid. These 2 carbons. So that 2 carbons will enter in the citric acid cycle. They will convert into the carbon dioxide. Carbon here. Carbon dioxide will out, and some molecule of ATP and lots of reduced coenzymes will be the output from this citric acid cycle. Reduced coenzymes, we are going to see that how do they work. Every step we are going to learn later on, one by one. So the reduced coenzyme, once the reduced coenzyme is formed, that is the energy carrier molecule. Another type of energy carrier molecule is similar to ATP. They carry electrons. They transport electron from the citric acid cycle, and then they release electron in the stage 4. That one we call is the electron transport chain or the ATP production. So they transfer electron, this reduced coenzyme, electron move from one molecule to another molecule. And we know that the flow of electron means what? Flow of electron will always produce some kind of energy. That's what the electricity is coming from, flow of electron. So here, in the electron transport chain, the electron will be flow from one molecule to another molecule, and that energy, will be produced, that energy will be used to synthesize ATP molecule. And oxygen will be required in this process because the oxygen will give ultimately oxygen will take those electrons. At the end, those electrons, somebody has to take those electrons. Oxygen will take those electrons and produce water. So that's the carbon dioxide we release from our food and the water in this system. So these are the 4 stages that we are going to learn one after another. So here is all the summary that we are going to discuss in this chapter. So next we are going to, tomorrow class we are going to discuss the digestion and the acetyl-CoA production. So that one will follow the carbohydrate metabolism, because we don't have enough time to look at the lipid metabolism and the protein metabolism, but we will learn the carbohydrate metabolism first.